Hey programmers, in this video series we're going to be looking into the internals of popular web apps and websites such as Spotify, Netflix, Tinder, Amazon and many more, in order to learn about different web development best practices from the industry leaders. Today's video is going to be about Spotify's cool looking web app, and without further ado, let's get started. Just like many of you, I've been a Spotify user for the last couple of years, and I've always been curious, how does it actually work under the hood? Because from what I can tell by reading their engineering blog, they're using a lot of cutting-edge technology. So I decided to dig a bit deeper, and that's what we're gonna do in this video. So first things first, I wanna open the developer console. But apparently by simply clicking on the right click, it's not gonna open it because they blocked it in the UI. So what I'm gonna do is simply open this pop-up, go to the developer tools and click here. And now we have the DevTools open. So I want to start from the very basics, and this is the architecture of the frontend app. By reading their blog article, it seems like they are trying to unify their developer experience for the web app as well as the desktop app. So what they essentially have is simply a React app, which is built with TypeScript, and they also have a Redux next to it. But the cool thing is that they put some library APIs that are dependent on some utility functions. And as you can see here on the left diagram, they have a web container, and on the right one, which belongs to the desktop app, they have a native container. So those are pretty much exposing some native and web related functions to the library API, and then React can grab those functions from the API and reuse it inside the app itself. So in the left one, it's very straightforward. I would say it's basically running in the browser. But on the right one, this React app is running inside the Chromium embedded framework. This is pretty much the same thing as Electron if you're familiar with it, although Electron runs together with Node.js, while Chromium embedded framework directly runs with C++. And speaking of the backend, I actually have a friend who works at Spotify. By the way, hi Marat, if you're watching this. And I remember him telling me that they use quite a lot of Node.js. So as you can see in this graph, they also put GraphQL and some REST APIs. And this is what the browser and basically the desktop app are communicating to. This is what when it comes to the architecture, but I just want to quickly validate whether they are indeed using React and Redux. So I could obviously go into sources, and the first thing that opens to me is the index file that we downloaded. I can already see something interesting here is that the only thing that we downloaded, well, as the first thing inside the folder is simply the index file and no other asset files. Because apparently all the other asset files like CSS files and JavaScript files are coming from separate CDN servers. I'm not sure why it is so, but I think we will look into this in a bit. So the HTML document looks pretty generic, although as in every big application, we have a lot of, let's say, link and scripts put in the, let's say, metadata put into the head, and we're gonna talk about these too. But I don't think I need to search for React here because I think it's being bootstrapped here. But when I open basically the settings, I can see that the React DevTools is already initialized. And when I click on this one, I can see that they are indeed using React. But the article says that they're using Redux, although it doesn't look like it because it seems like they're using React context. And I couldn't think of a use case where you would actually use Redux alongside React context, because they pretty much achieve the same goal, and this would be kind of a bad idea to combine them. But obviously the component names are anonymized because it's a production build, but still if you click on one of the components, you can see that they're using hooks, which means that their stack is pretty much up to date, and they're using a lot of memo and refs within the application. So this is pretty cool. Now I would actually suggest to go into the app itself and start playing some song, because I want to see how the application behaves as soon as we start playing, because playing a song is actually the main feature of Spotify, right? So let's open the network tab because I'm mostly interested in how the data is being fetched. Let's minimize this a bit. and I'm gonna clear the console, and I'm gonna play some Taylor Swift song because she's the best, I think. And I'm gonna press play, but also I will try to mute the songs for the copyright reasons. Okay, we got some data here, but it's too much, so I'm going to actually let the song play, and I'm going to clear the console to see if we have any new incoming data. Okay, let's go. Alright, so as you can see, we let the song play for around 10 seconds, and this was the first kind of a call that appeared in the console. I'm not gonna look into these ones because it seems like these are just events and they're used for telemetry and logging, but the first one looks interesting and it seems quite obfuscated. Let's make the DevTools a bit bigger. What we have here is that the request is made to this URL. Seems like it's audio.ak.spotify.com. And its code is 206. So it's partial content. And I can assume that it's actually the song that is being fetched because we are fetching the song progressively as the song is being played. And if we look into the file type, so let's see where the file type is. I think it has to be in the response headers. Yeah, exactly here, content type. And it says application octet stream. I'm not sure if you ever seen this type of content type, octet stream, but it was indeed something new for me. But what it is actually something interesting. So the content type octet stream is basically arbitrary data defined in RFC 2046. What this means is that the only purpose of this kind of a content type is to be saved to disk. This can be any kind of data that the server sends to the client without specifically defining what kind of a data this is going to be. So it's not like it's obfuscated, but it's very, very flexible. And if we look into the preview, we can see that this is basically a blob. So it's basically a raw data, and I assume there's some metadata inside. By the way, if you are curious about all the other headers like etag, expires, and so on, I have a video on it where I go over all the caching principles and everything you need to know about caching on the web, so please check it out too. But this is not everything when it comes to fetching songs. So Spotify is obviously not a piracy company, and they try to do their best so that the data that they're fetching is kind of protected so that you cannot download it directly, right? So what they used to have a couple years ago, or rather many years ago, is they had an encryption in place using Flash. But now, since no browser supports Flash anymore, they are using this new API called EME, and it stands for Encrypted Media Extensions. And it's basically available in every browser. And what it basically does, as a TLDR, is that it looks into the metadata that is being sent with the file, and the metadata is, I assume, somewhere here in the header, and it's gonna kind of use the specific keys and a specific way of decrypting the message, because this is not only raw data, but it seems like it's also encrypted. So it's gonna decrypt it, and it's going to be able to play the song. And this EME API is mostly applicable to media files, such as songs and video files. The brilliance of Spotify does not only end on this. I want to quickly tell you about how the Spotify actually is fetching the songs and how it optimizes them. So let's go to the Blackboard and imagine that we have some kind of a pie. And I'm going to distribute this pie based on some knowledge that Spotify has, or that we have, on how Spotify uses the data. So this pie is going to be divided like this. And I'm going to make this small section. And this small section is basically around, I would say, 8%. So let's change the color, make this 8%. And this 8% is basically the part of the song that is being fetched from Spotify's own servers, okay? So Spotify obviously has a server, and this is where the song is being fetched when you try to listen to something. Most of the data that you are listening to, doesn't matter web or mobile, here, so a big chunk of it is being fetched from your cache actually. So let's say I listen to this Taylor Swift song, and there's a high chance that I'm gonna be listening to her more and more, so pretty much every day. And it's Spotify is gonna know that, and it's gonna save the song in the cache so that it doesn't have to download it next time. So it's gonna play it from the cache. And you might ask me, what about this smaller chunk? So let's paint it in green maybe. What about this part though? Okay, and this part is what made Spotify kind of cool compared to its competitors. Well, Spotify uses P2P network. And what P2P network is, it's basically same thing as the torrent, if you've ever used it. So it's a peer-to-peer network, which means that if you have a device, let's say you have your phone here and you are listening to a song. Let's say you're listening to, I don't know, some random song, and I'm just gonna write it here. And Spotify obviously has a server here as well. And I'm simply gonna write server so that it's easier to follow. So the first, let's say 20 seconds or maybe 15 seconds, I'm not quite sure, but it's a very small fraction. Spotify is gonna download this part of the song from the server. And the reason is because it's fast. It's much slower to rely on a peer-to-peer network rather than Spotify's own server, which can be optimized by Spotify itself, right? So while you're listening for the first 20 seconds of the song, which was fetched very fast, you also have a peer-to-peer network of other users like you. So let's say we have like 2 here and maybe at another 1/3, but actually there can be 70 of them. Yes, exactly 70 or maybe 80 as well. That's what they say from their engineering blog. All right, and how are they connected? So let's say you listened for the first 20 seconds from the date song that was fetched from the server, at least a chunk of the song, and the rest is going to be fetched from the other users, just like you. Let's say your friend has a Spotify, and there might be a chance that your friend also has this song that you're listening to. So it's exactly this song. Let's say it's a Taylor Swift song. What are the chances that your friend also has this song in their cache, right? So if they have this song in their cache, your computer or your phone is gonna fetch it from here. And then it's kind of a group of people that are bound together, let's say by their interests, that your phone is gonna try to get this song from. And it doesn't connect only to one person, but it connects to a pool of, let's say, devices that it's going to fetch the song from. What it allows Spotify is that they're not going to rely on their servers. So there's not much stress on their servers, but rather on people's devices. So the trick is that if you have Spotify installed and you're playing some kind of song, it's kind of a fact and it's kind of a given that other people who are listening to the exact same song that you are listening are fetching the data from your device. Okay, this is very interesting. All right, I wanted to linger a bit longer on this network tab because most of the time the most interesting things are happening here. So I'm gonna clear this, and I believe we also need to make sure that the cache is disabled, and I'm gonna refresh the page and see what kind of an activity we have here. And I'm also gonna switch to all. And I refresh the page and we have some data. What I wanna do now is see how, let's say, the assets are fetched as I scroll down. Meaning I want to test the lazy loading. Okay, I'm scrolling down and I can see that we have again some events, but let's ignore them. But apparently we're fetching a lot of images. So, all right, these are basically covers of the playlists and albums that you are listening to. And it's kind of clever that Spotify fetches them lazily. As you can see, it first shows some kind of a color and then it shows the image itself. Let's see how well the images are optimized. So, seems like they are pretty well optimized, but I'm gonna sort them from the top like this. And we can see that something is wrong with the first image. So it's 1.2 megabytes. Why so? Okay, these are the chain smokers, and this is kind of funny because most of the images seem to be in a JPEG format, and they're quite optimized, but except the first two, so octet stream, exactly what we saw with the song that was playing. So these are basically an arbitrary file type, and I'm not sure why they forgot to convert them into a JPEG. Maybe this is kind of a cron job in their system that they convert every picture on demand, but apparently they forgot to convert these ones, and it's quite a huge file, especially if you're using the mobile version, let's say somehow, and you make your users download this huge file. And another thing that kind of bugs me is that they're being served over HTTP 1. I really don't get the reason why, because nowadays we even have HTTP 3 and still a lot of clients are using HTTP 1. I think it's time to switch from HTTP 1 to at least HTTP 2. But let's go back to the beginning, and I'm gonna switch to all again. And let's say I just want to restart the page and see how we are doing on initial loading to test the web vitals. Right, I'm gonna make this window bigger, and it seems like this is the part that is the most interesting for us. Okay, something went wrong, but I'm just gonna ignore this for the moment being, and I'm gonna make this waterfall file bigger. I'm going to sort the assets that have been fetched by waterfall so that we have a clear image on how everything was fetched. So if we minimize this a bit more, we can see that, okay, the loading is pretty good. I think we finished the loading in 2.5 seconds, at least the DOM content loaded, and the whole loading finished in 3 seconds. This is not too bad, I have to say, but again, this is also not ideal, especially the fact that, again, for some reason, we are using a lot of HTTP 1, of course, alongside with HTTP 2. So open.spotify.com is basically the HTML file that was first fetched. And then this HTML file was looking into assets that have been referenced in the head. If you remember from the source tab, we had all these font files and they had specific attributes called prefetch. Let's actually switch here. So these are the font files that we saw, and they have this rel preload, not prefetch, sorry. So it's a specific resource hint that tells the browser that it should start downloading a specific asset before others, but everything seems to be working well here. But again, HTTP 1 is kind of bad because, as you may know, HTTP has a limited number of connections it can establish with a single server for a single request. So it means that we have 1, 2, 3, 4, 5. So we have 5 connections, and it is able to establish one connection for all of them and download all of them in parallel. But I think the maximum limit for HTTP 1 when it comes to parallel connections is about 7.4, depending on the browser. So if you have more than 7 resources to load, obviously don't use HTTP 1. It's a really bad practice nowadays. One of the ways to alleviate that was obviously to target 2 different servers so that they are treated as 2 different servers. So you can basically multiply the number of assets you can fetch in parallel by 2. And apparently Spotify is trying to do the same because fonts are being downloaded from a different CDN than CSS files. So the fonts are coming from encore.scdn.co, while the CSS files are coming from open.spotifycdn.com. This is kind of interesting. I also don't get the point why they couldn't put all of the assets that are being fetched into one CDN. They could also do exactly the same when it comes to JavaScript files. And speaking of the JavaScript files, the same problem that we just discussed is apparently happening with JavaScript files. So these 2 guys are being loaded way too late. So this one and this one, web player seems to be the essential part of the app, and vendor web player, I guess some vendor third-party libraries that are present on the page, are being waited until all of these CSS and fonts are fetched, and only then it can start downloading the content. So as you can see, this orange line is the initial connection. This is the time that we need to wait until the other resources are basically done downloading. Again, if we would have used HTTP 2, because as you can see, these 2 resources can be fetched at the same time with other resources. But since these are HTTP 1 resources and from a different server, and of course, it's not always given that HTTP 1 connections are going to be initiated at the same time, apparently there was some render blocking script. So these 2 guys, the browser decided that they are going to wait until everything else before it has been finished. Of course, HTTP 1, the first solution, but to make it even faster, to optimize it even further, you can use resource hints, as we already mentioned. And this is all when it comes to Spotify and what I found interesting about the way they built their app. If you have any other ideas, or if you actually like this type of format and would like me to dig deeper into other apps, into other companies' websites, just let me know down in the comments and I'm definitely gonna take care of that. Hey there, it's me again. I just wanted to quickly say thank you very much for watching this video and smashing the like button. And if you want to stay up to date with such cool topics, make sure you subscribe so that you don't miss whenever a new video is out. And I'm gonna see you in the next one.